Today we're learning how to graph linear and nonlinear equations. In order to be able to graph these types of equations, you need to understand a few basic things about the quadrant system and the coordinate plane that we use. So here I've gone ahead and labeled the quadrants. So here we've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And I've also labeled the x-axis, which is the horizontal axis, and the y-axis, which is the vertical axis. In order to be able to graph linear and nonlinear equations, you need to be able to graph coordinate points. Every coordinate point is made up of two numbers, an x value and a y value. So let's say I give you the coordinate point 3, negative 1. You always graph the x coordinate first. So I'm going to go along the x-axis and find my 3 right here. And then I'm going to go down to negative 1, and we're going to graph our point right there. If you can graph coordinate points, then you will be able to graph linear and nonlinear equations. Let's go ahead and try graphing a linear and nonlinear equation. So here is our linear equation first. In order to graph a linear equation, you always want to start by making an XY t-chart. When filling in an XY t-chart, you can pick any value for x. So I like to usually start with 0. You're going to plug this 0 into the equation for x and solve for y. This is called a function. So I'm going to go ahead and say y equals negative, and instead of the x I'm writing a 0 and then completing the equation with plus 3. If I solve this, negative 0 plus 3 equals 3, so that means my y value for this point is 3. Next, I usually choose 1 and 2. You need to have 3 points in order to graph a line. So if I plug in 1 to this equation, I get negative, because we've got a negative here. In place of x, I'm going to write 1 plus 3 equals negative 1 plus 3 equals 2, so my y value is 2. Finally, I'm going to plug in 2, so I've got negative 2 plus 3 equals 1. Now that I have this table, I can just go ahead and graph the coordinate points. The coordinate point from this first row is 0, 3. Then we have 1, 2, and 2, 1. So on this coordinate plane, I'm going to go ahead and graph these 3 points. I've got 0, 3. So we'll go ahead and graph a point right there. Then we've got 1, 2. Oops, moved my coordinate plane a little bit. There we go. And then finally we've got 2, 1. Once I've graphed these 3 points, we can connect the dots using a straight edge. So I just went ahead and grabbed a straight edge, and I'm going to go ahead and connect these dots. If I could stop messing with my coordinate plane. There we go. Alright, so we have successfully graphed this linear equation. Now you should always add arrows to the end of every linear equation that you graph, because these equations go on forever. We could pick all values of x infinitely in either direction and plug them in to solve for y. Now let's go ahead and graph a nonlinear equation. We start by doing the exact same thing. We're going to make an xy t-chart. And again, I'm going to start with my x values, and I typically always pick 0, 1, and 2. When we plug in 0 for x squared in this equation, we get y equals 0 squared minus 1. 0 times 0 is just 0, so we then subtract 1 and we get negative 1. So our first y value is negative 1. Then I'm going to plug in 1 for my x, and I get 1 squared, which is 1 times 1 is 1 minus 1, which is 0. And then we're going to plug in 2 squared minus 1 equals 2 squared is 4 minus 1 equals 3. Alright, typically when you're doing a problem that is nonlinear, so in this case something that's x squared, you also want to pick a negative value. So here I'm going to go ahead and pick negative 1 as well. Make my t-chart a little bit longer, and we're going to plug in negative 1 for x squared minus 1 equals negative 1 times negative 1 is positive 1 minus 1 equals 0. As you can see, something that's a little bit different between this nonlinear equation and the linear equation is that some of our y values might be the same. That's okay. We're going to then go ahead and graph the points in this table. So we've got 0, negative 1, 1, 0. That's a really bad negative. Okay. 2, 3, and negative 1, 0. So 0, negative 1, graph right there, 1, 0, 2, 3, and negative 1, 0. So as you can see, if we connect these dots, this graph is nonlinear, meaning it does not make a straight line. However, it still can have infinite number of x values, so you need to put arrows on the end of the graph. So here we've shown you how to graph both linear equations and nonlinear equations. For this lesson, you also want to be able to determine whether or not given ordered pairs are solutions to the given equation. So here we're given a coordinate point, and we want to know, is it a solution for this equation? To determine this, you're going to go ahead and plug in the first value for x and the second value for y and determine if the equation is true. So here for y, I'm going to plug in 4 equals negative 2. Instead of x, I'm going to plug in 0 plus 4. Then I'm going to go ahead and solve. So negative 2 times 0 is 0 plus 4. 0 plus 4 equals 4. This value is equal to this value, so the answer is yes, this is a solution for this equation. Make that a nicer yes. Let's go ahead and try this next coordinate pair. So this time we're plugging in x and y, 1 for x and 6 for y. So I'm going to go ahead and put in 6 equals negative 2 times 1 plus 4 and solve. Negative 2 times 1 is negative 2 plus 4 Negative 2 plus 4 equals negative 2. Negative 2 and 6 are not equal. So that means that this coordinate point is not a solution for this equation. And we can continue to do this. So we've got negative 2 in for x and 4 in for y. 4 equals negative 2 times negative 2 plus 4 equals, this is positive 4. 4 plus 4 equals 8. These two values are not equal. So again, no, this is not a solution. And then let's go to this last one here. Negative 2 in for y, 3 in for x. When we solve this, negative 2 times 3 is negative 6. Negative 6 plus 4 is negative 2. Negative 2 equals negative 2. So yes, this is a solution for this equation. Remember that solutions for an equation are always ordered pairs, and these ordered pairs are every point that falls on the line or on the nonlinear equations graph. That's it for today.